When we're talking about exponential growth, we have a concept analogous to the half-life, and that is the doubling time. The doubling time is the amount of time it takes for a quantity to double. So, for example, we might be told that an investment doubles, which means doubles its value, every 27 months. If $50,000 is initially invested, we want to write an exponential function describing the value, V, of the investment after t years. So we want to measure our time in years. That's why that doubling time was converted to months for us. The starting value? Well, we invest $50,000, and we invest that at time 0. Right, that's the initial investment. This is doubling, so our multiplier is 2. And we double every 2.25 years. So our exponential model, we have 50,000 for our starting value times 2 to the power. Well, our starting time is 0, so we'll just have t over 2.25 is how long it takes to double, so t over 2.25. We can answer various questions with this, the most obvious one being, with that investment, well, what is it worth after 5 years? Right, so this is all the same given information that we had before. And we want to know what is it worth after 5 years. That is, when t is 5, we had v of t is 5,000 is 50,000 times 2 to the t over 2.25. What we want to know is what is v of 5. Well, v of 5 is 50,000 times 2 to the, plug in 5 for t, so 5 over 2.25. We can throw that into our calculator, and we'll take 50,000 times 2 to the power 5 over 2.25. And it doesn't tell us how to round. Let's just round to the nearest cent because we're talking about money. So we've got 233,305.81. We're talking about money, so that's $233,305.81 is what this investment will be worth after 5 years, if it doubles every 2¼ years. We might also be asked to find the doubling time. So here we've got what an investment pays described in terms of compound interest. This investment pays 3.1% interest, compounded monthly. So that means we have R is 3.1%, so 0.031. And N, monthly, means 12 times per year. Using the compound interest formula, the value at time t is the starting value times 1 plus 0.031 over 12 to the 12t. Okay, and we want to find t so that our p of t, p0 times 1 plus 0.031 over 12 to the 12t. We want to find t so that our principal has doubled, so that we get 2 p0. Assuming that our initial investment wasn't 0, we can cancel those out. So we know what to do here. We have this number to this power equals 2. That means our exponent, 12t, is equal to the log, whose base is this awful number, 1 plus 0.031 over 12. And we're going to take that log of 2. Dividing both sides by 12, we get t is 1/12 times. Now I'm going to write this in terms of the common log. Log of 2 over log of this awful number, 1 plus 0.031 over 12. Let's throw that into the calculator, see what we get, and then we'll see what it makes sense to round it to. So we'll have 1/12 times the log of 2 over the log of this awful number, 1 plus 0.031 over 12. Close that, get out of there, hit enter. 22.388, let's say about 22.4 years. So the doubling time for this investment is about 22.4 years.